This is a Math 3 lesson summary video for the lesson titled Optimal Solutions. The purpose of this lesson is for students to use geometric and algebraic concepts to solve problems in modeling situations. This lesson consists of two problems. In the first problem, students are given the volume of a composite shape, a cylinder and a hemisphere, and they're asked to minimize the surface area. In the second problem, students are given the dimensions of a composite figure, a cylinder and a sphere, and they are asked to find the radius that will double the volume if the height of the cylinder is kept constant. In this video, we're going to go over the first of the two problems. This problem involves a composite figure, which is a figure made up of more than one geometric shape. The silo in this problem is made up of a hemisphere and a cylinder. The silo has to have a volume of 614 pi cubic feet, and students are asked to find the height and radius of the silo that minimizes the surface area. Let's start by looking at the formulas for volume and surface area of cylinders and hemispheres. The formula for the volume of a cylinder is V equals pi r squared h. The formula for a volume of a hemisphere is 2/3 pi r cubed. To create a volume formula for this silo, we just need to add these two formulas together. For surface area, the cylinder piece of the silo can be found with the formula pi r squared plus 2 pi r h. This formula was created by adding the area of the base to the area of the side of the cylinder. The area of the side of the cylinder can be thought of as a rectangle that has been rolled up, where the height is one dimension and the circumference is the other. We do not need the area on the top of the cylinder because the hemisphere will sit on top of the cylinder. The surface area of a sphere's formula is 4 pi r squared, so all we need to do to find the formula for the surface area of a hemisphere is to divide by 2. Then, just as we came up with the volume formula for the silo, we just need to add the two surface area formulas together to create the surface area formula for the silo. In this problem, the volume of the silo needs to equal 614 pi cubic feet, and we need to find the height and radius of the silo that minimizes the surface area. To do this, we can combine these two formulas to create one function that relates the radius of the silo to the surface area. Since the surface area formula has three unknowns, surface area, radius, and height, we can solve the volume formula for h and substitute it into the surface area formula. Let's do this by first dividing both sides of the equation by pi, then subtract 2/3 r cubed on both sides, and then by dividing r squared on both sides of the equation. H equals 614 minus 2/3 r cubed all over r squared. Now we can substitute 614 minus 2/3 r cubed over r squared and for h in the surface area formula. Now, let's look at the graph of the function of the surface area to find the minimum value. With the use of Desmos, when x represents the radius and f of x represents the surface area, the lowest point in the practical domain is 7.169,807.234. This gives us the radius and minimum surface area, but we still need the height. To get the height, we need to substitute 7.169 into the equation for height, and we'll get 7.167 feet. In this problem, we started by identifying what the problem was asking, what geometric figures were being used, and what formulas were needed. Then we created equations by combining formulas, and we created a function that related the radius to the surface area. With the surface area function, we were able to use technology to find a relative minimum value of the function and solve the problem. That's it for this video. Thank you for watching.